Solka, IB Masters Learning Center at IBMasters.com. And today we're going to look at Test 7, Section 4, number 36, which reads, in the figure above, the tan of B equals 3 over 4. If BC equals 15 and DA equals 4, what is the length of DE? One thing is, let's say you have no idea how to do this question. You could still get it right. What do I mean? Well, first off, you label BC as 15. So the length is 15 from here to here. You label DA as 4. It's length of 4 from here to here. And then you could actually estimate, what do you think the length of DE? What is it? Why are you able to do that? Well, if we scroll back here, I'm going to show you a little something. It says this, and people don't pay attention to it. They read this. The proctor will read this in the beginning of the test. Figures provided in this test are drawn on the scale unless otherwise indicated. You want to use that to your advantage. So, literally, if you have, well, on test day, what you're going to have is you're going to have a piece of paper. You're going to have your booklet with all your questions. Number 36 will appear in that booklet. You're going to have a separate Scantron. You could literally measure the length of DA, and then you'd measure it up, size it up against DE. You would see that it's bigger. Measure another length of DA. So now we've got a length of 8. Measure it according to the length of DE, and you would find that the measure of DE would be exactly between the 4 and the 8. That's how you can get it right without knowing how to do it at all. Okay, now let's get to the math. So in order to do the math for this question, we've got the tangent of B is 3 over 4. One thing to keep in mind is that similar triangles all have the same trigonometric ratios. So, and another thing to keep in mind is that, hey, these are similar triangles. We're going to prove that they're similar triangles, and I'm going to show you how. So, first off, we have 90-degree angles at BDE and at BAC. And also, both of these triangles share this angle right here. So, since they have those two angles that are common, then this angle here must equal this angle here, because both triangles have to add to 180 degrees. So we know that they're similar triangles. If you ever see a construction like this, you know they're similar triangles. Okay, as long as DE and AC are parallel, or they're both forming right triangles in this case. So since they're not actual measures, tangent, cosine, sine, they're actually just ratios. The way you could do this is you could label this side. Remember tangent, remember so, ga, toa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So what's opposite? 3, because the tangent is 3 over 4 and adjacent is 4. But we don't know that those measures are 3 and 4, and chance if they're likely not 3 and 4. So what I'm going to do is I'm going to put 3x and 4x. Now that's going to maintain the ratio, because my x is 1, then the sides are 3 and 4. If the x is 2, then the sides are 6 and 8. So now what I could also do is I could label AC, let's label that 3y. And then I could label BA, I could label that 4y. So again, those sides obviously are not the same as the 3x and 4x sides, but they are going to have to maintain that ratio. So now, how could we solve this? Well, you might notice, if you've got a right triangle and the sides have a ratio, the legs have a ratio of 3 to 4, it is a 3, 4, 5 triangle. So in which case, the 15 would equal 5y. And then you could solve for y. The y is 3. You could plug in, solve for the other sides, which we'll get to. Another way to solve that, even if you don't see that there's the Pythagorean triple 3, 4, 5 triangle, you could do the Pythagorean theorem, which is a squared plus b squared equals c squared. Your a in this case, 3y squared, plus b squared. Your b in this case, 4y squared, equals c squared, which would be 15 squared. Okay, and then when you square 3y, you have to distribute that exponent. It's 9y squared plus distribute the exponent 16y squared, and 15 squared is 225. Then when you add them up, you get 25y squared equals 225. And this is with calc math, so of course you divide by 25, but anytime you have to do this on no calc math, think in terms of quarters when you have multiples of 25. How many quarters are there in $2.25? Well, there's 9. But anyway, if you divide both sides by 25, you will get y squared equals 9. Take the square root of both sides. You get, as I said before, y equals 3. So if y equals 3, then this side is 9. That doesn't help me much though. This side, 4y, 4 times 3 is 12. And if this whole side is 12, notice the dA is 4. So I do 12 minus 4, I get 8, which has to be the length of BD. So if 4x equals 8, then divide both sides by 4, you get that your x equals 2. And if x equals 2, then 3x is 3 times 2, which is in fact 6. And remember when I said before, if you measure the length of dA, then measure it again, and you mark those sides and size it up against DE, you would see that it's exactly between 4 and 8. So you'd know the answer is 6 without actually knowing any trigonometric functions at all. Thank you for joining us today. If you like this video, click like. You could share it with someone who has difficulty with trig or does not know this rule, that if it does not say figure not drawn to scale, then the figure is drawn to scale. You can trust the figure. If there's any question you'd like to see answered from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. Click subscribe so you don't miss anything. And check out the short video. I'm going to solve this in a minute somehow on YouTube. This is YouTube, on TikTok. Have a great day.